Yeah, you guys are on.
You can edit me out. You can pay for that. You know what you're doing here? Which one was that?
I would never record
Hey,
video.
I did look so bad.
Yeah. I got mine.
He could not record another video. Yeah, but it was effective. I figured out what the answer was. I'm like, okay. So I put this question by numbers here.
Minus -3. So yeah, plus 3. I should be -3. So -1. And then I had it down to 1.
No, remember 65.
Let's calculate. What do you expect?
It's like.
Okay, that's what you guys told me.
Okay, yeah.
It's like,
Sorry.
Yes.
But it's still -4.
That's a monster, yeah, because you hit. Okay, yeah. I had a five, I somehow changed the whole thing.
So then I wasn't.
What do we got? You got-
I was like,
wait,
wait,
it's like
so -9 plus 5 is -7.
Really, man?
that's fine.
Yeah.
I think I did it a different way.
What do you do?
Because I subtracted the 9 plus
I don't know what you
Okay, then you.
Yeah.
What did we do?
You got 97. You got the distance, you divided it by 2.
Okay, these are all bad.
And then you got the radius, and then you squared it out.
That's kind of cool. It's easy. I think it just runs off.
What?
And then you
It's easy.
add
It
it
just
on.
runs off.
Maybe it's my double.
They can just say the same. They can have it in
Okay,
here.
just maybe, okay.
That is.
We missed all the same time, because we got the same stuff wrong.
Amen.
Okay, like the second one's
It is just true. That was
to
fine.
me and
Bro, he ain't feeling you.
it's like it really just depends on the day. Lesson.
All right, did we get 97?
No academic.
Ooh, dollars and billions, okay.
Yeah, I don't remember the how. We had very slight clues. And like.
And I'm like, this is how I
Like, and then it was
Let
like,
him
I left her some.
All right, slope wise, what'd you get for, the slope as we go through here? Alex, what did you get for your slope?
I got 1.
1? Oh, wait a minute here. All right, -7 minus 5 over 1 minus -3, which should be a +3. So -12 over 4. Not sure what happened there. Double check there. But it should be, what is that, -3? Okay. And now I got y minus y1 equals m times x minus x sub 1. Doesn't matter which point you pick. I'm going to pick 1 -7. M equals -3. So I substitute in y minus -7 is y plus 7. -3x minus 1. -3x plus 3. Subtract 7. And y equals -3x. Did I do that right? -4? All right, to double check it, you want to plug the other point in to double check it. Okay, because if you made an algebra mistake within here, if you plug in this point, it's still going to look like it's correct. But in this case here, plug in -3, I get 9 minus 4, I get 5. Okay, so I do know it works. All right, the other part with equations of lines that you've had, and I want to hit again, parallel and perpendicular. Parallel lines have the same slope. Perpendicular lines have negative reciprocals. Negative reciprocal means if one slope is 2/3, the other has the flip and it's negative. If one slope is 5, the negative reciprocal is -1/3. Okay, so let's take a look at this third one. I need a line perpendicular to y equals 3x minus 4, passing through 9, -4. This slope is 3. So what slope do we have to use? The slope of the line we're looking for, or perpendicular to is 3, we need to use Negative 1/3. So you're gonna use negative 1/3. And I get y, and I'm gonna use y minus y1 sub 1 equals m x minus x sub 1. And then I get y minus negative 4 is y plus 4. Then x minus 9. So y plus 4, negative 1/3 x plus 3, and then subtract 4. And I get y equals negative 1/3 x minus 1. Okay. All right, you do need to know, this is what basically section 2.3. Now, we're not formally supposed to cover it under the syllabus, but you need to have a little bit of a refresher. This will come back up and we'll hit it again, but you need to find the equation of the line. And I suggest you use the y minus y1 equals m times x minus x1 for that. All right, homework wise, 90, here's your answer to 90. We'll talk about a couple of before that if you need, but at least check your answer for 90 if you would. Now you could have square root of 20, that just simplifies the 2 radical 5, but either one would be fine. That doesn't look right. What's from one?
I just like the
X squared plus y squared minus 4x.
like it must have been awful.
Minus
I kind of feel bad. I feel
Oh,
bad.
yeah, you're up now.
He was such a good guy. He just absolutely.
Yeah, we did everything bad.
We were
It's like open right now.
And all the people like took like class seriously and stuff. Like we were messing around.
That's how we learned.
Yeah. Yeah, like mess around.
Yeah, I like that.
I hate that last year she wrote right there. Just so slow and you're upside down for so long.
What you copied? All right, 85, real quick here. This is one, either you get it right away or you just sit there and look at it and you can't figure it out. It tells you the center is 1, 2, and it says it touches the x-axis. We got to make sure you understand what that means. If it touches the x-axis, it means that is the outer edge. So it comes around and it hits it at that point. Let's see if I can draw this.
Oh, okay.
There we go.
Okay.
So that's what it looks like. For the circle, you need to know the center, you need to know the radius. Do we know the center?
You do.
We do. They give you the center. They tell you the center is 1, 2. From this information, the question is, can we figure out the radius? And yes, you can. If that's a center and it touches the x-axis, that's got to be the radius, 2. Okay, so this is really all you need. Now your equation is going to be x, r equals r squared. So it's going to be x minus 1 squared plus y minus 2 squared equals r squared. Well, r squared is 2, so it's going to end up equaling 4. Okay, so that's how you get that one. So if it says it touches the axis or it touches a point, that means that the outer part of the circle, the outer edge of the circle will hit that, and then you can figure out usually what your radius is by going from the center to that point. Okay? All right, other questions on that homework? Okay, other questions on that?
87.
All right, 87. The endpoints of a diameter. What are those endpoints, if you would?
74 and then negative 36.
You can draw it out if you want, it's not necessary. Those are the endpoints of the diameter. Diameter has to go through the center. That means the midpoint will be equivalent to your center. So we got to find the midpoint of these 2 points. So 7 plus negative 3 is 4, divided by 2. 4 plus 6 is 10, divided by 2. My midpoint is 2.5, which means that's also my center. Well, what else do we need to know? You need to know the center, and we need to know the radius. You got 2 options. You can either take either one of these 2 points in the midpoint, find the distance, that's your radius, or what I think most people did was they usually just took your 2 points here and found the distance between 7.4 and negative 3.6. And that is x2 minus x1, that's going to be negative 3 minus 7 squared, plus 6 minus 4 squared. When you're done, you get the square root of 104, which is 2 radical 26. Well, that's your distance, but it's also the diameter. Well, we need a radius. What do we need to do? If we know the diameter to get the radius, just cut it in half. So cut this in half. That's where you get the square root of 26. So your final equation, x minus 2 squared plus y minus 5 squared equals square root of 26 squared gives us 26. Okay, so that's how you do 87. So those are 2 ones you just had to be careful with. All right, we're going to move into 2.4. I do have guided notes for you. Let me hand those out. Oh, sorry.
You're good. So I can
Oh, you're doing easy pass or? You grab the thing at the beginning.
Thank
Okay, there's only very few people that call me good.
And I want
Are you on the cross country team?
I'm that.
It's those cross country teams in Oxford, you know, with all that.
Yeah, that's not jazz. I just use jazz to say.
I love
So guys.
Yeah.
Yeah, we did it. Mitchell thought I was a board member. I worked at board, but he's a good friend.
Come on. We'll get it.
Yeah, as long as you know.
Well, no, I think you're right. I was like, what is that? It was the influential points in the history. And like, there was like a game of like 5 people. And they're like, points in history.
Really, that's
And they say something, and the crowd applauds.
So bad. I can tomorrow, that means I have that early. And he does, yeah. Am I responsible for you though? I'm just kind of like, no, you're my phone and like. So.
All right. Just some definitions here, dealing with functions and relations. And yes, you've seen this before, but typically you don't remember everything on here. But any set of ordered pairs is called a relation. Usually in math, we're going to build relations based upon equations. You plug in x, you get back y. That's your ordered pair. The set of all first components is called the domain. The set of all second components is called the range. Okay, so finding the domain and range. First few times doing that, I think it's a little shaky. I think as you get further along, you get a better grasp of domain and range as we move forward. A function, okay, that does have a specific definition. So a function is a relation, and we talked about this before, in which each element of the domain corresponds to one and only one element of the range. So each x goes to one y. We don't really want a situation where an x can go to two different answers. All right, two just cases here of sets. You got the one domain, you got the one range. I imagine there's ages. Based upon that definition, does each x go to one range? Yes, it does not matter that they go to the same range. Okay, that's all right. But each x goes to one range, so that is a function. Now, a very, I think a good case here is when you're dealing with like numbers, phone numbers. So Malcolm there can identify with an office phone in a home. Maria, office cell at home. So obviously each member of the domain does not go to one member of the range. This is not a function. Okay, not a function. Now dealing with graphs, what you've learned in the past is a good old vertical line test. If no vertical line intersects, okay, the graph of a relation at more than one point, then the graph is of a function. I usually reword that, just basically say, if a vertical line hits it twice, then it's not a function. Because what's going to happen is you have an x coordinate. Say A goes to C, A goes to another value B. We don't want A to go to two different numbers. Therefore, it's not a function. Vertical line test. First one there. Okay, if you move this vertical line, will it ever hit it twice? No, so this one is a function. And now on the second case, whoops. Now it doesn't have to hit it twice everywhere, just at any point. So right there it's fine, but as soon as you take it any further here to the right, we're going to hit it multiple times, so this would be not a function. So not a function. Okay. All right, now when we're talking domain, it's a lot of times easy when you see in a graph. You're going to have to work when they give you just an equation to understand what the domain is. Two key things. You got to keep this in mind in all cases. And if these don't come into play, then your domain is all real numbers. It means you can plug in anything. But you cannot divide by zero. Okay, that's undefined. Now a little bit for number one, the shortcut. I say division by zero is undefined. You can also think about that as no zeros in the denominator. Either way you want to think about it. Division by zero is undefined. I cannot have a zero in the denominator. And the second key thing is the square root or any even root, although square roots are probably 98% of what we do. We don't deal much with fourth or sixth or anything, but square roots of a negative number is not a real number. Which means only positives, and I should put in here and zero under the square root. You can take the square root of zero. Square root of zero is just zero. Okay. But those are the two key things we're always looking for that makes something I'm not a member of the domain. Division by 0, square root of a negative number. Okay. All right, take a look at that equation down there. What would be the domain? What would be all the numbers I can plug into that for which I get an answer back? Okay. What are all the numbers that I can plug into that for which I get a valid answer? First of all, can you plug in the number 10? Just you pick a number. 2 times 10 is 20. 20 plus 8 is 28. Can we take the square root of 28? 10's in the domain. How about negative 10? 2 times negative 10 is negative 20, plus 8 is negative 12. And take the square root of negative 12? No, so it's not in the domain. Now we don't want to do number by number. That would take forever. All right. What can I do here? Or what would be the case? Anything under the square root has to be bigger than or equal to what? 0. So we want to find out where 2x plus 8 is greater than or equal to 0. This basically just comes down to an inequality. Any number that makes that greater than or equal to 0. We'll solve that. 2x is greater than or equal to negative 8. X is greater than or equal to negative 4. Domain, and I want all your domains in interval notation. It's going to be from negative 4 to infinity. Go ahead and graph that on your calculator if you would. All right, hopefully the graph makes sense in terms of the domain. We said x had to be greater than or equal to 4, which means the graph cannot exist below negative 4. There cannot be any part of that graph. So it starts right here at negative 4. Couple key things you can look at. The table. Okay, be able to go to the table and interpret that. Well, anything below negative 4, when you plug in negative 4, I get back 0, but after that it says A. Okay, doesn't work. So that graph will only show up to the right of negative 4. Now, we don't know about the range at this point, okay? We can interpret that later. Right now, we're just worried about the domain. So understand what we can plug in and get back an answer. All right, so that one is going to be x. Well, let me do something here. Okay, so there's that graph. Now, the second one. All right, 6. First thing you want to look at is the domain all real numbers? Should it exist everywhere? And the answer to that is, are there any square roots? Is there a square root here? No, so that doesn't restrict it. Will I run into a case where I divide by 0? Yes. So then I got to throw that out. So that means the denominator cannot equal 0. So 2x plus 6 cannot equal 0, which means 2x cannot equal negative 6. X cannot equal negative 3. It can equal anything else. It can equal anything else. All right, before we write down the domain, graph it. All right, we say x does not equal negative 3. if I go to my table, at -3, it says error. Any other number you plug in should give you an answer back. All right, now make sure your graph looks like that. And you might have to put the denominator in parentheses if it doesn't look that way. All right, how do I label the domain and interval notation? Okay, what would that look like? Okay, I'm going to put the domain and interval notation for that. Oh, Nathan Popio, any ideas?
No.
No? All right, so how do I write everything but 3? Okay, everything but 3. How do you write everything? 1 second. How do I write everything? Negative infinity to infinity. Okay, Audrey, are you leaving?
No, but I can answer the question.
All right, answer the question.
Negative infinity to -3, not included,
Okay,
and then the little u thing,
yeah, you think, union.
yeah, and then -3 not included, so infinity.
Correct. That's how you exclude 1 point. That's how you exclude one little point. You just go to -3, we say -3 is not in there, union -3 to infinity. So you got to include everything up to, but not including 3. When you have that, you're going to have 2 pieces of your graph. Okay, here's your first piece, there's your second piece. Okay, so anytime you have a break in there, you have to write that as a union. Okay, it's a union. All right, turn it over on the back. All right, copy that one down if you would. All right, have a good weekend.
Bye, have a nice weekend.
Good luck
Thank
tomorrow.
you. Thank you so much.
Nally.
Yeah, so lucky.
Ah, darn.
If you get this one right, I'll think about it.
I'll let count on that.
All right, let's take a look at what we got going on here. Cannot take the square root of a negative number. You cannot divide by 0. Both cases come into play, right? I got a square root. That has to be greater than or equal to 0. And then when I subtract 7 and then divide by 2, I get x is greater than or equal to -7/2. X minus 5 cannot equal 0, which means x cannot equal 5. All right, I want you to think, how can I combine those 2 facts and come up with my final domain? Okay, what's my final domain going to be? All right, I'll let you think about it. Adam wants to answer it, so we'll let him take first crack at it. You got something for us?
I think so.
All right, what do you got, Adam?
Bracket -7 to, and then 5, parenthesis, and then union, and then parenthesis 5 to infinity, parenthesis.
Oh, man, good.
I get to leave now?
Wish I could let you. That's it. -7/2 of 5, union 5 to infinity. How many pieces of the graph do there have to be? 2 distinct pieces. Okay, this one starts at -7/2. So I'm going to do a quick graph of it. So we go to y equals. Let's see here. Clear that out. Second square root 2x plus 7. Close it, put it in parentheses, divided by. And then this also needs to be in parentheses, x minus 5. Graph. So there's one piece, there's your second piece. Now it's not as obvious because right here you're not sure, does it just go towards the x-axis or does it stop? That's why you might want to look at your table and you see at -4 it'll say error. -5 it'll say error. So it doesn't exist. So it starts at -7/2 or -3.5. And that'll be that case there. Okay. All right, g of x equals square root of x plus 5 divided by x squared minus 6x plus 8. Okay, what do you think we need to do to the denominator? We're going to factor it. We want to know where it equals 0. And that's why we factor things so that it's easier to see. So I'm going to factor that into x minus 4 times x minus 2. X minus 4 times x minus 2. All right, now let's take all the pieces that we know. I know that x plus 5 has to be greater than or equal to 0. And that means x has to be greater than or equal to negative 5. I know that x cannot equal 4. And I know that x cannot equal 2. Okay, because now we can make the denominator 0. All right, what's your final domain going to be? What's your final domain? So you got to combine all these pieces. It's got to be greater than or equal to negative 5. It means you cannot be anything to the left of it. And then you got to take into account can't equal 2, can't equal 4. So started at negative 5. And it's going to go until it hits the first spot. The first spot it hits, it can't equals 2. So negative 5 to 2. Union. Union what? From 2 to 4. Good. Union 2 to 4. Then we have a break at 4. Union 4 to infinity. So how many pieces do there have to be on the graph? There has to be 3. All right, graph it, make sure it looks right. Make it a fraction.
I did this like 3 years ago and I've never changed that.
Okay, what does that middle piece look like? It's totally separate from those other two, right? It opens down? Okay, so you're going to get 3 distinct pieces for that. So negative 5 to 2, 2 to 4, 4 to infinity. Anything else will give you an undefined answer. All right, we're just going to do these next two. If I give you a finite graph, okay, you need to be able to look at that and tell me domain and range. All right, look at that first one, think what the domain is, think what the range is. Domain are all the x values that show up on the graph. Just the x values. The range are all the y values that show up on the graph. Well, if you take a look at that, all right, for the domain, it's going to be the lowest x value to the highest. Well, the lowest one is negative 2. We follow it all the way to 3. It does not include negative 2 because that is a open circle. So parentheses negative 2 to 3, but it does include 3. All right, look at that range. Okay, so think about that. Tessa Miller, what do you think about the range?
I got parentheses 1 and 4 bracket.
Good. Make sure you go all the way up to the highest point, which is 4. Don't go to the last point and put whatever its y coordinate is. Whatever the highest point is. Doesn't matter where it occurs. All right, domain for the next one. You got 2 pieces. The first piece goes from negative 3 to 1. It includes both the negative 3 and the 1. Union. All right, how do you define the second part of that one? It's just an arrow going to the right, but where does it start at? It starts at 3. So union 3 to infinity. Okay, union 3 to infinity.
Is that 3 included in that?
Yes, it is included. Burkett, you're on fire today. Or who said it?
I said it.
That's what I thought. You're on fire. All right, what about the range? What about the range? Now, that last one, you just gotta watch how you write it. It goes from -1 to 1, inclusive. All right, union. All the y values, well, every y value in that line is just what? 4. So you really only got 1 point. When you got 1 point, we don't write it as an interval, we just write it like a singleton point, 4. And you use braces, okay, for that one. All right, so domain, range, the definition of functions, relations. We're gonna finish the rest of that Monday, but there is a homework assignment, not many problems, but a few. What? Did it record? Yes.